Mario, Monday, September 8th, 2025. This is a simplified schematic diagram of the MOSFETs. These are working in P and N channel complementary MOSFET setup here for the ESC section to this control board for the Quark SRB helicopter that I show in some other videos. So I wanted to show the simplified diagram for anybody that may be wondering. I'm saving you some work here. If you have something the similar helicopter or the same helicopter, I should say, and you're working on an issue with the speed control. So the speed control section for this this board is located right there. It's right next to the where the connectors for the brushless motor, main motor, and then the cordless motor is just a 2-pin connection right next to that. And so right behind there are three MOSFETs, and those are labeled. Let's see if I can zoom in on this section right here. I don't know, for some reason my camera does not want to zoom in here. Come on, baby. Okay, so there are three MOSFETs behind these connectors. Those are labeled TQ, and right underneath that are three other MOSFETs that are labeled TX. I already gave a cross-reference to some part numbers earlier that you can buy, and those are those part numbers from DigiKey right there. Basically, the electronic circuit setup, it's arranged in similar way to this circuit that I have here, where you have the MOSFET, the P channel MOSFET connected to the plus side, and the N channel MOSFET connected to the negative side, which would be the ground, just like that. And so I've minimized all the internals of the MOSFETs and just made this block diagram, just calling it gate, the source, the drain, gate, source, drain. And so this is the P channel, P, N channel, and I have these arrows here right next to the gate to indicate the P and an N channel. Basically, if you look at the schematic for an N channel, you have these arrows right here pointing towards the gate. That's an N channel, and away from the gate, that's P channel. So I've simplified that, and that's what I'm showing here in this diagram right here. I've also made the connections, from each one of these three-phase circuits to the motor, to the brushless main motor, and there's an additional N-channel MOSFET, which would be a TQ, labeled TQ, on the underside of this of the circuit board. So there's actually 4 MOSFETs right underneath here. And you have to undo these connections here. There are two pin connections. Actually, there's a 4-pin connection here, 2 pins here and 2 pins there, and you have to cut those and resolder those. When you close this again to complete the circuit between the ESC section and the receiver. But basically, that's the circuit that's driving the motor right here, the main motor, and also the tail motor, which happens to be a coreless tail motor, just an N-channel MOSFET connected that way. Why isn't my camera focusing? Okay, so my camera is having a little difficulty focusing for some reason. So basically, that's about it. I've determined which MOSFETs are P and N channel. I traced the connections. Which MOSFETs were connected to with the source connected to the ground, and which MOSFETs with the source connected to the plus, and so that's how I determine which ones are P or N channel. So this is it's a good reference circuit board. Because this helicopter operates via 2S LiPo, that's 8.4 volts max. So that's the voltage that's driving these MOSFETs. Now the replacement MOSFETs that I got are they have a 20 volt. They're rated at 20 volts. The max voltage across the drain and the source voltage, so that should be fine. I mean, we're only operating at 8.4 volts here, so there's plenty of room right here. They are also rated at 7.4 amps. Now I did another video where I showed the current draw on this main motor is about to start. When it starts, it's about 4.5 amps. And then when it levels out, it's about 3 amps. Not counting the tail motor, which I just added another amp, so total max 5 amps, and that's the reason why I went with this 7.4 amp MOSFETs here. I could have gone with maybe a 7 or 6, but these were more complementary to each other. The other ones were a little bit off in voltage. These are both 20 volts at 7.4, so the specs are the same, except that one's P and the other one's N channel. So, if you want to keep this for reference, you're welcome to do it. So, if you have any questions, put them down in the comments, and I'll try to answer them.